We saw so far very good examples on city levels. So in my closing presentation, let me zoom out again and see from Europe's point of view whether and if there are measures that can help us in achieving compliance with the new proposed standards, and also whether we will be feasible in the long-term future by 2050 to ensure full compliance with the WHO air quality guidelines. So a very short roadmap of my presentation. So I will start with some very high-level information about the trigger points of what I'm going to show today, and then some test cases before closing with the main highlights. So what has been the trigger point for us in Concawe to develop not only this study, but a major part of our Concawe air quality program? And let me put together some key questions that we would like to address through our activities. And let me start with the first and most important question. Where we are now, what is the current status of air pollutants concentrations in Europe, and what is the compliance status? Then also, how different sectors contribute, and whether already legislated measures are effective enough to achieve compliance with the proposed air quality standards by 2030, and or if close alignment with the new WHO air quality guidelines will require additional measures by 2050. Then also, do we only speak about legally binding values? Do we also need to care or talk about target values, and also how air quality modeling can help in better assessing air quality and managing air quality to different areas? And also, where do we need to focus in the coming future? Thomas said about supersites, about pollutants like ammonia and others that are not regulated. So where do we need to put our research activities in the future? As I said, first question, where we stand now. It has been already said, we're doing extremely well in achieving compliance with the existing standard. It's a map of Europe that I'm showing here, showing the different stations, the entire European monitoring network, measuring annual PM2.5 concentrations, and with the different colors, you see those stations that are measuring PM2.5 below the 25 micrograms per cubic meter, the existing standard. And the map shows us that we are pretty well, like full compliance is achieved in Europe with the latest data that have been taken from the European Environment Agency. Are we good? Well, depending on the comparison that we are doing and depending on the metric that we are using and the value. And on the right side, what you see now is a similar comparison, but now having as a standard the WHO air quality guideline of 5. Well, obviously, we are not doing very well in achieving this guideline, so we are having an entire European non-compliance issue with PM2.5. And this actually poses the new question, what do we need to do? Where do we need to focus? What are the actions that we need to take? And we always say in Concawe that understanding your emission source is a key. So look on the left side, this bar plot that shows how emissions of PM2.5 in Europe will project over the future from 2020 to 2050. CLE is the current legislation scenario as it's described in the European Commission's second Clean Air Outlook. While also we have some cases as the MTFR, we will talk later on, is the maximum technical feasible reduction scenario, and another scenario combining MTFR and also some climate measures. So what is fact is that we are reducing emissions of PM2.5. What is also very interesting to show is that we talk about the dynamic world, about the dynamic situation. So what we know now as significant contributors for PM2.5, domestic heating for 2020, will not be the case in 2050. So measures are taken into the different sectors and will change the picture looking into the future and with respect to the sectoral contribution. What also is very important, and Paul mentioned before, is that road transport exhaust is not a significant contributor. It will be the non-exhaust element that will have the highest contribution in terms of PM2.5 transport-related emissions. A similar figure for NO2. On the left, what we have now in comparison with the 40, we saw, and it's evident that we are almost at a full compliance status with the 40 micrograms per cubic meter. It's not the case when we try to compare with the updated WHO air quality guideline value of 10 micrograms per cubic meter, with almost 75% of the stations in Europe having NO2 concentrations above these 10 micrograms. And a similar figure and the pie chart for NOx. Again, we see a significant reduction of NOx emissions from all sectors, and in particular road transport. With the fleet turnover, there is a projection that by 2050, there will be almost 90% less NOx transport emissions in Europe, while it's also very interesting to see that traditional sources like road transport that we see a lot of actions that are taken will not be the dominant contributors as we are moving to the future, and in 2050 other sectors, including shipping, will be will have the most significant contribution. All this made us to perform this modeling study that Paul mentioned previously to try to forecast predictions of air pollutant concentrations across the European monitoring network from 2015 till 2050. We used the same methodology that the Commission used in their impact assessment study with the same scenario. So we started with 3 activity scenarios of the second clean air outlook, the current baseline scenario, where there is an assumption that we have all emissions, all measures that are subject to existing legislation, both affected and yet to come into force. And then we also examined 2 extreme scenarios. One is called MTFR, where we assume that in all sectors, the technologies that deliver the maximum reduction potential are implemented, the so-called MTFR, and then we combine this with some climate measures as they described in a 1.5 live scenario. As I said, understanding your source, understanding your sectoral contribution is key. That's why we also examined some sectoral scenarios where we removed the emissions at each sector every time. So 6 additional sectoral emission scenarios, and of course our study focused on the major pollutants, PM, ozone, nitrogen dioxide, covering all Europe, and having recently a report published by Concawe. Now, as I said, some results from what we did so far, and let me spend some time to explain the figure starting from the left. What you see now on the left side is the percentage of the monitoring stations in Europe measuring PM2.5 that are not meeting a certain metric, a certain criteria, meaning the WHO air quality guidelines or the interim targets. So with the purple, we have the percentage of the stations that do not meet the 10 micrograms per cubic meter, which is the proposed new standard in the directive by the Commission. And also with yellow is actually the relevant fraction when we do the comparison with the WHO air quality guideline. We talk about baseline scenario, we talk about 2030 towards 2050, and the predictions show that meeting the Ambient air quality directive proposal of 10 micrograms per cubic meter will be challenging even in 2030. There will be around 25% of the stations above this limit under the current legislation, which is decreased, and by 2050 we only have non-compliance issues to less than 10% of the stations. While compared with the WHO air quality guidelines, yeah, this is a major European issue to try to meet this guideline value. The question then is, what do we need to do more? And this is the relevant figure when we assume that the MTFR measures are taken into consideration. Of course, we see reductions in terms of non-compliant stations over Europe from 2030 to 2050. But it's also interesting to know that more than 50% of the stations are still above the WHO air quality guideline by 2050, which is shown with the yellow bar plot. This is at a European level. Air quality, though it's a multifactorial problem, we see a lot of variability among the member states, and this is clearly illustrated here in this figure that shows the same results per member state by 2050 when we compare the stations in terms of achieving the WHO air quality guideline of 5 micrograms per cubic meter. So you see that there are some member states like Estonia or Finland that we are able to meet and to have this full compliance, but the majority of the member states are still having a significant issue in terms of compliance with the WHO air quality guidelines under the current legislation scenario. Now, the question is that what do we need to do in order to go faster, as fast as possible, to this WHO air quality guideline? And as I said, we try to understand better all different sectors, and it's clear to say, we heard a lot about agriculture, that this should be the key sector that needs to be addressed in the future in order to help all member states go faster to this compliance, to this WHO air quality guidelines. This doesn't mean that all member states will achieve full compliance, but at least it shows an indication, at least where we need to focus first in order to accelerate the compliance with the WHO. This was for PM2.5. Similar figures now for NO2. Looking now the 2030 and 2050 world under the different scenarios that we examined. So case 0 is the baseline. Case 7 and case 8 were the MTFR and MTFR plus 1.5 live scenario, and the scenarios, the cases between are the sectoral sensitivity scenarios that we examined. Well, for 2030 now, it's obvious to say that NO2 will have, we will see a significant improvement in terms of compliance. More than 90% of stations are predicted to meet the new air quality standard of 20 micrograms per cubic meter, but still, we are having significant issues in achieving compliance with the WHO air quality guidelines. And it's also something that we notice in 2050, that at least there are around 10% of the stations in all scenarios that we examine that will still measure NO2 concentrations above the 10 micrograms per cubic meter, which is significantly different compared to the European-wide issue that we are facing for PM2.5. Now we are talking mainly about hotspots. That means that we need to go into the areas where we are having the issue. We need to take actions that will be mainly city-specific. And I tried with these two examples to illustrate why we need these targeted city-specific measures. I have taken Amsterdam and Brussels as examples. These are the predictions for 2050 under the baseline. So you see in both examples that we are having issues in terms of compliance with the WHO. What will make the most important role? Well, in both areas, by zeroing road transport, we might see some changes, some improvements in some areas with the different dots is actually the different monitoring stations located in the two cities. But what will make the most important effect will be targeted measures. So for Amsterdam, zeroing aviation and shipping, it seems to be the dominant effect in terms of compliance. Still, we will have stations that will measure above the 10 micrograms per cubic meter, while for Brussels, it will be the public power sector that will make the biggest impact in comparison with the other sectors. So, just to conclude, what we have seen so far is that meeting the new proposed air quality standards by 2030 and the WHO air quality guidelines by 2050 will be challenging for some pollutants. We need to understand the contribution of the different sources, the availability of the control measures, also the technical feasibility in order to better understand how fast we will go to meet these new standards. And also, we will probably need targeted region or city-specific measures based on a thorough source apportionment analysis in order to have a highest impact. As we say, perhaps traditional sources like road transport might not be effective enough, might not be significant in the future, and other non-traditional sources like shipping, as we have seen so far, that may play an important role. We do believe that air quality modeling can play an important role, and with respect to binding limit values, we feel and we see that cases like ozone will probably require further analysis, further research in order to better understand the formation before setting any binding limit values. With that, I hope I'm doing well with my time, only 40 seconds late. Thank you very much for your attention.